Talking about domestic hot water, so large circulating multi-loop hot water systems. Identify some of the common issues, what happens or what the impact is for uncontrolled temperatures in a system, and then introduce you to some of the changes that are happening in the market today by introducing some emerging technology, particularly in automation on the balancing side of domestic hot water. A little bit about myself. We'll get over to it. I guess we'll look at the learning objectives. Before we really get into the domestic hot water system itself, I wanted to just give you an overview of managing building water systems, particularly on the potable water side, and just the key objectives so that we get a good picture of what owners, operators are looking for, or what they're experiencing, or what's important to them in managing their building water system. Like I said, I've explained some of the impacts, and we'll look at some of the emerging technology that's out there. My name is Greg Swafford. I have 20 years of experience as a plumbing designer and project manager at various MEP consulting firms. I now work as the technical sales manager for George Fisher Piping Systems. And I also have several certifications, certified in plumbing design, green plumbing design. I sit on the committee, the ASHRAE 514 committee for risk management of building water systems, physical, chemical, and microbial hazards, and also certified Legionella water management specialist. So we got several areas to talk about today, several opportunities for us to do a deep dive. I'll try to avoid that, but try to keep it higher level, move through quickly so that we can have plenty of time for questions and discussion. So key water management objectives. When you're looking at managing a building water system, there's really four key components that operators are looking for. The first one, in no particular order, the first one is comfort, so occupant comfort. And as we talk about building water systems, we're talking about keeping hot water hot, delivering it quickly, keeping cold water cold. That's what we're talking about. Safety, particularly with potable water, where occupants have access to it, potential for scalding, or microbial hazards such as Legionella bacteria. Or sustainability, obviously maximizing our water and energy use, and then operational efficiency. And this really has to do with the facility operator, facility director. How easy of a system is it for them to maintain and to keep operating at peak performance? And then also, what are the impacts from a operational cost perspective? And the reason I focused this on domestic hot water and got really specific outside of just building water systems in general is because hot water and how it's operating, if it's not operating at peak performance, it's going to touch on or impact all four of these key objectives for your clients. So we'll dig into it a little deeper here. Occupant comfort. And when we're talking about domestic hot water, we're really looking at how quickly are they getting hot water. Long wait times for hot water. If there's particular areas of the building that are taking longer times to receive hot water, that'll impact that experience of the user. Particularly in hospitality settings, right? What's really key for a hotel manager or someone that owns a hotel is getting hot water as quickly as possible to every guest room. And why that's important here is because it can have a direct impact on their revenue. If you've ever stayed at a hotel, I've not had any issues here at Caribe Royale. I was at a conference last week, a hospitality conference in Baltimore. We had this discussion with several people, and many of them brought up the fact that they were staying at the Hilton that they were experiencing this exact issue. So what that means then, especially in the hospitality market, really a lot of competition, right? There's typically groups of hotels within a certain area. If you have a bad experience at that hotel, the likelihood of you going back there is pretty slim. So delivering hot water quickly can have a direct impact. I just kind of, some of these, I guess these little calculations, consider them kind of napkin calculations. I've did a real deep dive into a lot of them, but this is Hilton's property, what their average daily rate was in 2019. I use 2019 obviously because 2020 was kind of a scratch, and 2021 still had some issues. But you look at the occupancy, the daily rate, the occupancy rate, and the estimated annual revenue. If for whatever reason a customer has a bad experience, they go on booking.com, they put in a poor review, or they decide to just never go back to that hotel again, if their occupancy rate just drops 0.5%. So we're not talking about going from 75 occupancy rate to 70, we're talking about going from a 75.7 occupancy rate to 75.2 occupancy rate. They could potentially lose over $100,000 that year. So occupant comfort, that experience of the user is important and can have a pretty significant impact for your facility. The second one is on the safety, and really predominantly talking about scalding and Legionella. Uncontrolled temperatures can create significant risk, whether if the temperatures are too hot to increase the potential or the risk of scalding, or if those temperatures begin to be kind of too low and get in that Legionella risk growth range. Legionella pneumophila has a particular range that it likes to grow in, that it likes to proliferate, and it is a problem and a growing problem in the United States. Over the last 5 years, they've seen an increase in Legionella cases to the CDC of over 550%, and it's a growing concern. Lots of factors for it. We won't dig into all of them, but some of them really do have to do predominantly with flow, so water age in a system, stagnation, and temperature, setting an ideal temperature within that building. And this might not be the best title, buildings designed to grow Legionella. They're not really designed, that's not the intent, right, when they're designed, but the way that we design buildings and operate buildings really do increase the risk potential of Legionella growth in the system and transmission. And we talk about, particularly, let's look at warm water. So the highest risk or the highest probability or the number of cases typically come from the domestic hot water. It's the first draw on domestic hot water. When you start seeing large community cases or large impacts, cooling towers is really one of the higher causative agents of that. Warm water, so as we're talking about scalding and Legionella growth, and I'll do my best. I know I keep moving that way. I'm going to move to my left a little bit here. But when we talk about scalding, right, so preventative measures for scalding is obviously mixing valves, tempered water. At that point, though, as you reduce or minimize the risk of scalding, you also could potentially increase the risk, though, of Legionella growth, creating a hospitable environment for Legionella bacteria to grow. And then stagnation. We all, how many are familiar with Hunter's curve and how you size? Yep. Hunter's curve was established around 100 years ago. Obviously, the way that we use fixtures with our push for low flow fixtures, we're still sizing based on Hunter's curve to where, 3 gallons per flush or 5 gallons per flush, whereas now we're down to 1.1 gallons per flush. But we're still sizing if we as if we still had that same demand. And so what that means then is we're using less water, but we've sized it so much that we're going to experience some lower flows in those big mains and branches in your building, or potentially stagnation altogether, which again is a hospitable environment for bacteria growth. All of that is fine if you don't have a mode of transmission, which buildings do. Showers, faucets, spas, humidifiers, whirlpools, cooling towers. Here's a little bit about the temperature growth range. These temperatures were from done in a laboratory environment, so obviously buildings with a lot of scale, corrosion, biofilm growth, these temperatures may be off, but right here we're looking at an uncontrolled temperature in a building on a domestic hot water system. You are potentially right in that ideal growth range in parts of your building. So if your system is unbalanced, you're not maintaining consistent temperatures all the way through it, you could have an environment that's conducive for bacteria growth. Uniform Plumbing Code, I think this last cycle added this in the appendix, and this here kind of buttons up that topic of the scalding risk versus Legionella risk, right? So there's some things that we've done to conserve energy, lower water heater set temperatures, reduce the risk of scalding, some different things like that that have an unintended consequence that can cause or create that environment for Legionella growth. So when plumbing systems are really susceptible to this outside of mechanical systems or electrical systems, right? We can live without those. We don't want to, right? We can live without modern indoor heating and air conditioning. Mankind's done that before. We can live without lighting and power or electricity. Mankind's done that before. But we can't live without clean, safe, drinkable water. Can't do it. But historically, plumbing systems have been dumb systems. We don't know, it's kind of a set it and forget it thing. Well, we just let the water run. We just, as long as water's coming out of the faucet, everything's good. But it does have a significant impact on us. And I'll try to button up this Legionella topic here quickly. But I wanted to spend some time here and really bring your attention to it, that there really is a risk associated with hot water systems, and this is why it's important that we're able to maintain consistent temperatures when we're thinking about building domestic hot water systems. Other thing to point out, as cases continue to rise, insurance companies are starting to fight their liability or their responsibilities for covering Legionella-related issues. And then in addition to that, there's also significant cost potential if there is a case that's reported, obviously through either litigation, remediation efforts, and prolonged loss of business. It could run into the millions of dollars if there's a case. So the third piece, or the third part of water, the impact of managing water uncontrolled temperatures is water waste, obviously, so sustainability. If it's taking a long time, this is how they're all interconnected, right? If it's taking a long time for a customer to get hot water, what are they going to do? They're going to turn their shower on, they're going to go do other things, waiting for that water to come out. So what happens? They're using or wasting more water, and they're wasting that energy that was initially used to heat that water, and then they're reheating water again. And then with that increased energy use, obviously you're increasing greenhouse gas emissions with that as well. This is ideally how water should be used. You have the tap water energy that's getting from the water utility to the building. You use energy to heat that water, and then you use that hot water, and then there's energy associated with the wastewater. Ideally, this is how it should operate. If you're maintaining hot water temperatures consistently throughout your building, able to deliver it quickly to every guest or every fixture, this is ideally the way that you can maximize that, or the most efficient way of using energy. But what happens, you have long wait times, you have that tap water energy, hot water energy, they turn the faucet on, it runs, so you've got the wastewater energy for that water. Now you're heating up more water, you've got more draw on your tap, and then you're reusing. So you're basically doubling that effort, that energy, that water waste. And again, here's an example. Assuming you have a almost 300 key hotel, 10% of those rooms have to wait 4 minutes for hot water. What's that impact from a water waste and energy use standpoint? You can see it here. Over 100,000 gallons of wasted water, the potential energy waste, and then the additional greenhouse gas emissions, just by having a 10% in those block of rooms. So maintaining a consistent hot water temperature throughout your building is important. And then finally, operating costs. It's estimated that $2.5 million is spent annually in the US on energy associated with hot water systems. How many of you are commissioning agents, do retro commissioning, or tab consultants? Those, okay, all right. So when you're looking at an existing system or a new system that you're starting up, I wanted to go through real quickly how to identify a hot water source or a problem or a hot water issue. So I'm going to make some assumptions. We're going to assume that the piping system was routed properly, installed properly. We're going to assume that it's all insulated as well. So in a hot water system, or it's common, you have your hot water generator or your water heater. You have some type of mixing valve, a master mixing valve. You have balancing valves on a multi-loop system, and you have a recirculation pump. So as you're starting to identify or look for sources of hot water issues, I always say start at the beginning and end with the circulation pump. So you start at the water heater. That one's relatively easy to identify if that is the source of the problem. Am I generating the hot water temperature that I want? And am I providing enough hot water at peak demand? And if I'm not, then it's potentially my water heater that's the issue. So you start there. If you've got the right hot water coming out, you've got enough to meet the peak demand, move on to your mixing valve. Mixing valves are notorious. I put thermostatic here because those tend to have more issues, be a little more sensitive to how they're installed than some of the digital mixing valves. Mixing valves, if you're looking at it having problems on the outlet side, if you're constantly too high or too low on that outlet temperature, that's an issue with your mixing valve. Not necessarily the mixing valve itself, but it's right there, right? It's either the way it's being piped up, it doesn't have the proper check valves, there's an issue right there. Again, mixed water temperature fluctuates on the outlet. If you're seeing water temperatures that are too high after a period of low demand, so overnight there's no draw on the system and that temperature starts to creep up, what's happening right there is potentially a piping issue, that return line is piped back to the water heater and not also piped back to the mixing valve. If you have temperatures that are too low overnight, what's happened then is that return line is not piped back to the water heater, it is just piped back to the mixing valve, so you're going to start seeing low temperatures overnight. So looking at those common issues, that'll help you to define if, okay, is it a mixing valve issue or a piping issue right there at the mixing valve. This one potentially is the biggest issue, and we really haven't addressed it. When we start looking at technology for water heaters and their efficiency, that has definitely changed over the years, right? That they've become more efficient, so they've got higher turn down rates, and we've got condensing water heaters and heat pump water heaters. Mixing valves, digital mixing valves have been out now for several years. Starting to see many manufacturers have that option. That helps to alleviate some of those installation issues or operational issues that mixing valves have had in the past. System balancing is a little more challenging. And I wrote here that balancing is potentially the most challenging portion of the hot water delivery system. When you have a properly balanced system, you're able to get and maintain hot water temperatures throughout. So if there's particular areas of long wait times, say you're getting the right water temperature quickly in certain parts of your building, long wait times in other portions of your building, that is most likely or a key indicator that your system is not balanced properly. What can impact it, right? Just because, and I'm not going to put poor commissioning or poor tab, we're going to assume, everybody here has never had an issue with getting hot water temperatures, right, consistently. But over time, not just over time, but new buildings can have an issue with startup and getting that system balanced properly. You guys spend a lot of time working on that. But over time, also as the building is operating, gets turned over to the owner, you see scale buildup happen. That's going to cause issues with your balancing valves. Again, a lot of times when you get into an existing building, you turn it over, it's been a set it and forget it for the owner. They don't maintain those valves, they neglect it, they have renovations or repairs and they don't go back and check the balancing of the system or how that impacted the balancing of the system. And again, neglected maintenance. And bottom line is most existing balancing systems are having issues. And what happens though, a lot of times what'll happen is we just adjust our behavior, right? If it takes a long time for hot water, we just let it run longer, right? Instead of actually addressing or trying to identify that key source of the problem. And then as we move to the end of the system, that's when we look at the recirc pump. So once we've already eliminated the water heater as a problem, the mixing valve as a problem, confirm that the system is balanced, then look at the recirculation pump and see if it's properly sized, see if there's some issues there. Because a lot of times what we kind of default to is after we evaluate the water heater, say there's not a problem, and we say, well, the pump is a problem. So then we go back and we try to increase the size of the pump. That can create some other issues. You're increasing the velocity in those lines, could potentially accelerate corrosion, degradation of some thermoplastics, and then also cause some pitting in copper or metal piping. So that's how my recommendation on identifying the source of some hot water issues. Start at the water heater, work your way systematically through the system. So now we'll dig into the balancing part. Like I said, most likely the most complicated or the one that you can have the most issues with. So with that said, we've seen an evolution of technology or solutions in the market happening over the last several years. Obviously, the manual type balancing valve is still the main guy, still the one that is predominantly specified by engineers and predominantly used in the market. Because of the potential issues, that one being a little more complicated, the potential issues that it has and a little more time consuming, it's obviously balanced in a static condition when the building's not operating, but once that building starts to operate, there could potentially be issues with those differential pressures and the different demands, and that could cause, we could see some problems there. We have independent, or pressure independent type that came out. We're starting to see thermostatic balancing valves used more and more. And now as we've got a renewed emphasis on healthier buildings, that, in my opinion, I try to look at things half full, be optimistic about stuff. One of the benefits, I think, of going through COVID the way that we did is this renewed emphasis on building health, right? Renewed air quality concerns or attention to air quality, attention to healthier water, healthier environment for buildings. As we see that now, we start to see more technology introduced into building water systems to make buildings healthier. And we'll dig into that component. So automated or electronically actuated valves. We're doing on time here. I'm going to kind of blast through these here. Some of the characteristics, benefits, I think you're all familiar with the circuit setter type of balancing valve or the manual balancing valve. Obviously, again, the most predominantly used one in hydronic applications or in plumbing applications. Have some good benefits, obviously the lowest component costs, but then there are definitely some challenges in making sure that those systems are balanced properly. Fixed flow, so these are your pressure independent balancing valves. They have cartridges that dynamically adjust to maintain that flow based on pressure differential across that valve. Engineer specifies that they want half a GPM, 1 GPM, whatever it comes factory set for that. Some of the challenges there, it's got a small orifice that could potentially scale up and then making that valve inoperable. So fixed temperature, these actually have a wax element inside of them. They're going to dynamically adjust. This particular type is a fixed temperature. So it comes again, the engineer specifies they want 120 degree return temperature or 115 degree return temperature. This is factory calibrated to that temperature. It gets installed and then they dynamically adjust throughout the day. So some may call them automatic balancing valves. And there is a difference between automatic and automated. We'll talk about it, but this here is just basically the wax elements is either expanding or contracting, trying to hit that target temperature. Because of the potential of those types of valves being installed and either the wrong valve getting installed, the fixed temperature one, say you want 115 degree return temperature, but for whatever reason, the contractor installed 120 or 125 or 130, that's definitely going to impact how that system operates. And so what has evolved from that is the adjustable temperature. So now there is a dial, still thermostatic in the sense that it has that wax element that's expanding and contracting, but this allows you to make changes to it. And then on the automated side, as I mentioned, there's a difference between an automatic and an automated. Automatic, there is a physical response to a change, right? Whether it's the pressure independent type, it's responding to pressure changes just in a physical environment. Same with the thermostatic. It is just simply, it's not intelligent in the sense that it is just wax expanding or contracting based on temperature. That calibration had to have happened at the factory. With an automated valve, it is actually gathering data, and that data is being used to make a decision for that valve. So it's a more intelligent operation, it's a more intelligent way for that valve to respond and to react. With automated valves, you also have multiple choices in how to balance your system. You can do it dynamic by temperature. So in that, you set at the control panel, you set that desired return temperature that you want. The system then and those valves dynamically adjust to hit that temperature throughout the day, thus maintaining a consistent temperature throughout your building. Your tab report is really simple. You just go and you export that report. Now you can turn into the engineers and say, hey, the system's balanced. It makes your job easier. The other way you can do it static by temperature, similar concept. At startup, you put the desired return temperature in, it dynamically, or it adjusts to make sure that you're hitting those temperatures, and then it freezes that valve in that position for 24 hours. And every 24 hours it makes an adjustment, and then it takes historical temperature data to find that optimal position. So here we're using intelligent systems to make them operate and work more efficiently. You can also do it by flow. So if your client or your customer is interested more in the flow aspect, you can also do it there. So having automated valves, it increases that intelligence in your system. You've got better control, better monitoring. And why is it important to introduce technology into the plumbing side? You know, historically, plumbing systems have been the dumb system out of, you know, whether it's power and lighting. We've got some really intelligent systems there, helps with system efficiency, power use, energy savings. Automation has been used for a long time in other industries, whether it's in industrial processing, chemical processing. On the HVAC side, we see some automation that takes place, again, to operate that building more intelligently, gives you more data, gives that operator a chance to know exactly what's happening in your building. But historically, plumbing systems have never had that type of interaction, right? Might have a pressure gauge somewhere, might have a temperature gauge somewhere. Outside of that, you might connect to a building management system if you've got, you know, for a sump pump alarm or sewage ejector or you know, elevator pump. But outside of that, it's really just been, hey, it's got water in the pipe. How hard can it be? We'll let it run, right? One thing I want to point out here is plumbing systems are starting to get smarter, more intelligent. We're seeing more manufacturers offering connected systems, whether it's connected faucets, connected flush valves, more intelligent information for your digital mixing valves, you know, a plethora of introductions. And just because something is digital doesn't necessarily mean it's going to improve something, right? So example, so digitization, and I'm going to have a hard time saying these words, especially, but I may have to say it slower. Digitization is simply just taking something from analog to digital, right? So an analog clock versus a digital clock. Is there really a value in that? Just because something's digital doesn't mean that it's added value to your customer, right? Now, digitalization. So once you make something digital, and now you've taken it that next step using that digital information, whether it's stored files or temperature sensors or pressure sensors, something like that, and then using it in a way to improve a process or improve an operation. That's digitization or digitalization. Automation then takes that a step further. It performs repetitive tasks based on commands and rules. So when you talk about automation, it operates within this box of commands and rules. It's either on, off, adjust this valve if you see this information. You know, so it starts to get into more processes, more efficiencies, helps us to work more. You know, obviously, automation's been used in the automotive industry to build cars. I mean, there's definitely some advantages there in automation. And then machine learning. Obviously, I don't think we're at that point yet in the plumbing industry, but we're starting to see definitely talks, definitely momentum to move that way. So not necessarily artificial intelligence, but machine learning. And for an example, automated balancing valves have that opportunities, particularly when we're talking about that static by temperature or static by flow. What it's doing is it's gathering historical data and then making a decision. So it's not a decision that the operator is making, but that is saying, okay, here's this historical temperature data, here's where the valve positions have been over that time, or here's what the usage has been. This would be the optimal position for this valve to be in. Now, what to consider when you're looking at like an automation system, particularly on the plumbing side, is it needed? Again, is there value by digitizing this system? Is there something that we're adding value to an owner or to a customer or to your process? Where does it add value? Is it easy? Is it simple to design, install, operate? Is it flexible? Or now if I put restrictions on its use or restrictions on the facility manager? Project impact, how is it impacting your project? What are the risks? What does it cost? So when you're looking or considering either recommending an automation system, talking to your engineering group about it, these are some of the things to consider when you're looking at incorporating intelligent system into your plumbing system. And here I talk about the automation and the next logical step for plumbing systems. This is where you can use it to optimize water and energy. This is where that energy savings comes in, that energy use comes in. We see it with variable speeds recirculating pumps used on domestic hot water. That's relatively a new introduction into the market. It's able to either speed up, ramp up, slow down based on pressures, based on flow, based on temperatures. So it helps on the energy savings piece. As I said, it also maintains that consistent temperature throughout your building. You're definitely going to save water and energy. You're able to monitor and log data, right? This is the more data that you have, the more intelligent decisions you can make based on your system. Or as you're evaluating, doing a retro commissioning, the more data that you have out front, the easier it's going to be to help you identify or pinpoint an issue of problem. Some of the key operational benefits of using automated systems, particularly on your domestic hot water balancing, is that you're delivering hot water quickly. We talked about that and why that impact is. Managing those risks of Legionella. Again, temperature control or maintaining temperatures is one of those key fundamental control measures for managing bacteria growth. And it enhances water management for some of those facilities that might be healthcare facilities that are required to have an ASHRAE 188 compliant water management program where they have to identify control measures, they have to do monitoring, they have to have reporting. Having a digital system or an automated system is going to give them extra benefit. From a control standpoint, how do you control these types of systems? There's 3 different options. Obviously, there's the control panel that you can operate standalone that direction or that way. You can integrate it into your BAS or BMS system, or some manufacturers have the option for remote-based or cloud-based remote access. In that scenario, you're looking at maybe a client or a customer that has multiple buildings, multiple locations, and want to be able to see and operate from that standpoint. System startup is relatively simple. When you start getting into an automated system, really simple to walk through that step to make sure that you're getting that system operating properly. System is basically or virtually a plug-and-play application, and it's ready out of the box for preset factory values, but there is potential for definitely customization when you're talking about an automation system. Let's see how we're doing here. All right, we're good. Energy savings potential. Here's one of the reference projects, one of the very first in an automation system. What it was is that it was an existing hospital. So over the years had multiple renovations, additions, hospitals constantly doing some type of work, right? They're constantly moving things around, moving patient rooms around, moving operational places or rooms around. This one had experienced significant changes over the years and had chronic issues with their hot water because of it, because they never had a commissioning agent or a tab agent coming out helping them review as they started doing these additions, what is the impact going to be on our system. So the objectives there. They also had this particular reference study was done in Germany. They had some national control and documentation requirements where they had to store at a certain temperature, deliver at a certain temperature, return at a certain temperature, and they had to be able to prove that they were doing that. So they had those requirements as well. They went in, replaced 72 balancing valves. The entire system, once they went to start up, once it was replaced, they started it up. Took about 60 minutes in total for them to see those temperatures throughout their building that they were looking for. So pretty amazing results. That helped them because one of their responses to long wait times in further parts of their building, they said, well, how about we increase the water heater temperature? Maybe that will help us get those temperatures out there further. But by being able to have a consistently balanced system, they were able to reduce that water heater temperature, operate more efficiency, experience less heat loss, and they were saving around 15% on their energy savings. So having smarter systems, intelligent systems really do impact that operation. Here's an example scenario. This one here, let's say we've got a hospital that's experiencing chronic hot water delivery issues in one of the patient's wings. And again, resulting in long wait times. Facility engineer goes, increases that water heater temperature, hoping that that's going to help save it. Maybe they installed a larger pump using more energy again. That solution, they replace 10 mixing valve or 10 balancing valves with an estimated installation cost of around $10,000. I put this together just to try to give you an example of some type of ROI on that energy savings once they're able to consistently maintain those temperatures. They were able to reduce that water heater temperature and then have that energy saving potential and how it pays out over the course of a few years. When we talk about automation systems and the cost versus new construction, you're really talking about a fraction of a percent when you're talking about construction costs and how an automated system can help with that. All right, well, thank you so much for your time today. I hope it was educational. You learned some things. Obviously, I'll be around for a little bit if you have any questions. Thank you.